Good morning everyone and welcome to today's webinar. My name is Keira Proctor and I'm the Managing Director here at the A. Proctor Group, and this is the 18th webinar in our series and the final one for 2020. Since starting our series in April, we've covered a wide range of topics across all areas of the building envelope: fabric technologies, regulations and guidance. All 18 webinars and accompanying Q&A sessions are available to view on demand here on our YouTube channel, or at www.proctorgroup.com, where you can also register for CPD certification, order product samples and book in for online follow-ups with our team of experts. Today, we're going to take a look at the refurbishment and upgrading of existing buildings and some of the common problems that can arise. Meeting the increasing demand for housing has been a challenge for some time, and this has only been exacerbated by the changes in priorities and circumstances brought about by COVID. Even factors in the boom in DIY during lockdown have boosted the appetite for building refurbishment, with everything from redecorating to home office conversions taking place across the country. Combining this demand for housing with increased emphasis on sustainability and the recycling of existing buildings becomes an effective and attractive solution. Alongside these practical benefits, upgrading existing structures can play an important role in preserving the aesthetic character and individuality of towns and cities. The Architects Journal's recently launched Retro First campaign is a good example of the drive to shift policy away from demolish and rebuild to a retrofit first approach. So, today we'll be looking at some of these factors in more detail and considering the aims and outcomes of refurbishment projects alongside the types and scopes of refurbishments. We'll also look at the methods, frameworks and guidance used to assess technical performance of existing structures and subsequently quantify the effectiveness of upgrade works. Then moving on, we'll discuss the concept of inherent technical risks associated with particular systems and works, before finishing up with a look over some common scenarios and the fabric-first solutions that may be applied. Building refurbishment is a very wide-ranging topic which encompasses a great many different types of structures and systems. But to simplify things a little, we can consider most projects will fall into one of three principal categories: conservation and preservation, upgrades and improvements, and repurposing or change of use. Each of the three types of project will require a different balancing of priorities and will necessitate a different set of trade-offs to meet the overall goal. Having a clearly identified and realistic outcome in mind before beginning works is therefore a very important part of this design process. Conservation and preservation projects, especially those on listed or historic structures, have a number of limitations that may not be present in other types of refurbishment. Even if retaining the actual period material is not required, the preservation of the essential character and any decorative features certainly is. This requirement can place limits on the extent to which, for example, energy performance can be increased, or may restrict the approaches that can be taken to reduce air leakage or control condensation. Balancing the intelligent use of materials with the realistic expectation of what can be achieved and agreeing a suitable approach with any regulatory bodies is an important prerequisite. Establishing constructive dialogue between designers, contractors and regulators early in the project cycle helps to ensure costs and schedules are kept under control whilst delivering quality results. Projects where the main focus is upgrade and improvement work flip these requirements, so the primary concern is meeting a performance-based objective. That's not to say preserving feature becomes unimportant, just that the balance shifts more in favour of enhancement than conservation. Although the layout of the building may still impose limits on what can be achieved, particularly in areas such as window and door openings, there is usually a lot more freedom to accommodate fabric insulation, service runs and other modern requirements. Some thought must still be given to achieving this in the most cost-effective manner, as even with conservation considerations, making substantial improvements to the fabric performance can incur significant costs if not carefully managed. Finally, the last category is changing the actual purpose of the building itself, which can range from subdividing a large dwelling into flats, for example, or to conversions of formal industrial sites. Depending on the purposes of the building before and after conversion, each project will have its own unique challenges, with acoustic performance being a particular concern when converting from non-domestic to domestic use, as many non-domestic buildings, even relatively modern ones, were never designed to incorporate significant acoustic insulation. In this case, as with thermal insulation, airtightness and controlling moisture, the first critical step in any project is assessing the performance of the existing building. This achieves two important aims. Firstly, identifying and prioritising required works, such as repairs, and secondly, establishing a baseline relative to which subsequent improvements can be judged. While converting a bedroom to a home office or other basic DIY level projects have a pretty clear functional or aesthetic objective, larger scale refurbishment projects require a much more structured and objective approach. We'll move on to take a look at what structured systems can be applied later on, but first we'll take a quick look over some of the basic building physics we need to consider when working with the fabric of an existing building. The movements and interactions of heat, air and moisture are what influence most of the decisions we make when upgrading a building fabric, so it's important to have at least a basic understanding of the mechanisms involved. We've covered these topics before in our series of webinars, so if you'd like to learn about this in much more depth, those webinars are available on our YouTube channel or at our Learning Hub at www.proctorgroup.com. Firstly, we'll take a look at heat transfer. And there are three main mechanisms by which this takes place: conduction, convection, and radiation. Conduction takes place when two objects are in direct physical contact, and the heat energy transfers from one to the other. This process will continue until either contact is broken or the two objects reach the same temperature. Convection is when heat is transferred by a fluid medium, such as air or water. This happens because where the fluid is next to the warmer surface, it heats up. The warmer fluid is less dense than the surrounding colder fluid, and so rises up and is replaced with colder fluid, and the process starts all over. This sets up a circular current moving heat between the two objects, which will occur until this movement is restricted, the fluid is removed, or the temperatures equalise. Radiation is the final mechanism, and in this case, heat is transferred directly by means of infrared radiation. The first object emits the radiation and the second absorbs it. The rate at which the energy is transferred is determined by the emissivity of the respective materials. In a building context, these properties interact in various ways, but for a simple example, let's look at a timber frame wall with insulation placed in between stud-work. This insulation, let's assume is a mineral fibre, has a thermal conductivity of 0.035 watts per metre Kelvin. This property is constant irrespective of the thickness of the insulation. This is also known as a K value or lambda value and is a measure of how well heat flows across the insulation. If we have 150 millimetres of this insulation, we can divide this thickness by the thermal conductivity to give us a thermal resistance or R value of 4.3 metres squared Kelvin per watt. This does vary with thickness and is linear, so if we halve the thickness, we halve the R value. The higher the R value, the better the material resists heat transfer by conduction. The amount of heat flowing through the entire wall assembly is quantified using the thermal transmittance, or U value, which is calculated by adding all the R values together, then dividing one by the result. The U value is measured in watts per square metre Kelvin, and a lower result is better. Old solid brick or stone walls have a U value of 2 or higher, whilst a modern new build timber frame wall will be below 0.2. So this really is an area where substantial improvements can be made in older properties, albeit not always easily. The simple U value doesn't tell the whole story, however, as not all the layers in our example wall are continuous. The insulation in a timber frame wall is typically between studwork, which has a higher thermal conductivity and will therefore allow more heat flow. There are also windows, doors, corner junctions and floor zones to consider, all of which will affect local heat flows. This phenomenon is called cold bridging, and we account for this by adjusting the U value of our wall to account for additional timber and applying a correction called a psi value to account for the corners and floor junctions. By adding continuous layers of insulation or insulating around structural timbers of steelwork, we can reduce these corrections and improve the overall heat loss. Conductive heat flow is not a linear property, however, so the more we want to reduce it, the harder it gets to make further improvements. At modern levels of insulation, it is therefore not always practical to accommodate enough extra insulation to make a meaningful difference, so we must look at reducing other heat transfer mechanisms if we want to improve further. The other main area where we can improve our energy performance is by reducing heat losses through convection. This means ensuring unplanned air movement in the building is minimalised. Gaps, cracks, and poorly sealed penetrations in the building fabric can all allow a substantial degree of air movement, which not only means cold air entering the building in the form of drafts, but also warm air leaking out. Residents of old houses will be all too familiar with drafts and how much difference basic steps like using a draft excluder or taping cold old sash and case windows over the winter months can make. And when applied across the entire building envelope, it can add up to a dramatic improvement. The main benefit to reducing air leakage is that it doesn't necessarily add any thickness to the wall or roof. This means in older properties, space can be maintained and period features like cornicing can be preserved. There are a few ways to improve the air tightness of older properties, which we'll consider later on, but it's important to consider the effect it can have on moisture in the building. All activities that take place in buildings introduce moisture into the internal environment, and while drafty older buildings might have been a bit chilly to live in, this air movement allowed an easy route for moisture to escape. If this moisture cannot escape properly, it can lead to condensation problems, where warm, moist air contacts colder surfaces. Alongside this, traditional building materials like lime mortars and lath and plaster walls have very different hygrothermal properties to their modern equivalents. This means that the way they store and transfer both liquid water and water vapour can vary a lot, not least because older materials tend to have highly inconsistent properties. If we seal up all the drafts and upgrade the insulation without a proper understanding of this existing fabric, we can introduce problems with condensation or damp ingress that cause damage to these materials, often in ways that are hard to detect and remedy. For example, adding a rigid foam internal insulation system with a low vapour permeability to a lime-plastered stone wall will make the stonework colder, increasing the risk of condensation between the stone and the new insulation. This reduced permeability also limits the capacity for moisture in the stonework to dry out inwards. A more permeable solution can offset this by allowing more drying, but will allow more vapour, allowing it a more complex problem than it may first appear. So, when we upgrade our buildings, we need to carefully balance the benefits modern materials can bring against the risk of upsetting the balance of heat and moisture interactions present in the existing fabric. So how do we avoid these types of issues? The first step is to assess the existing fabric thoroughly, and there are a number of tools and frameworks available to undertake this. The best practice guidance for undertaking energy efficiency focused refurbishment projects is outlined in the PAS 2035 and 2030 documents issued by the BSI. The PAS, or Publicly Available Specification, details the steps, assessments and risks associated with each stage of the process, from assessment and design through to completion and handover. While the PAS 2035 approach is aimed more towards commercial or larger scale projects, such as local authority upgrade schemes, the steps and recommendations are applicable to every refurbishment project. The document itself also provides a useful framework to highlight the factors that should be considered to deliver any project successfully. It specifies requirements in the following areas: assessment of dwellings for retrofit, identification and evaluation of improvement options, design and specification of energy efficiency measures, EEMs, and the monitoring and evaluation of retrofit projects. The ultimate aim of the standard is to ensure projects deliver a healthy and fit-for-purpose environment for the occupants whilst respecting any preservation considerations. The principal factors recommended for assessment are U values of the various elements such as walls, roofs, floors, doors and windows, Psi values of junctions and other non-repeating thermal bridges, condensation risk throughout the structure and the balance of moisture flows, heat gains from occupants, appliances and solar, ventilation rates and indoor air quality. As PAS 2035 is focused on energy efficiency, It doesn't include acoustic performance in this list, but that's also well worth considering, especially in change of use projects. Undertaking acoustic testing as early as possible in the project will allow acoustic upgrades to be designed and built in more easily than if applied retrospectively. While the other areas on this list are relatively predictable and can be assessed by calculation with a reasonable degree of accuracy, the same cannot be said for acoustics. Making sure the existing performance is properly tested before starting work allows the acoustic impact of all upgrade works to be factored in, whilst changes can still be made easily. So, what methods do we use to assess these factors? The simplest step in the assessment is determining the U-values of the existing envelope. There is a range of software available to undertake this, such as the BRE U-value calculator that we use here at the Proctor Group. Whatever software is used, it's important that the calculation method itself conforms to the methods given in the relevant standard documents, principally BS EN ISO 6946. As well as using compliant software, it's important that the calculation is conducted properly and any assumptions made are in line with accepted conventions. The standard methods and conventions for undertaking U-value calculations are given in BRE Guidance Document 443, the most recent 2019 version of which is undergoing consultation right now. This document gives guidance on the incorporation of thermal bridging, adjustments for fixings and air gaps, and other factors that can influence the final calculated result. Whilst there's a lot of scope for interpreting these factors differently in refurbishment jobs, it's important designers have an understanding of how these work when comparing calculations from different sources. Whilst most software include material libraries, it's important the properties accurately reflect the existing building fabric, as it may not be appropriate to substitute the values given for modern materials. Building on the U-value calculation, the next step is hygrothermal assessments. Moisture control measures in building are detailed in BS 5250, the 2020 edition of which is due for release soon. BS 5250 references two standards for condensation risk, EN 13788 and EN 15026. EN 13788 uses the steady-state Glacier method to determine condensation risks, and our example here uses the ICOND software, which is linked to the BRE U-value calculator. This adds an additional layer of values to account for vapour transfer, and as with U-values, it's important to ensure the values for permeability are appropriate to the building fabric under consideration. Glacier uses steady-state heat conduction, along with average monthly temperatures and vapour pressures to identify vapour diffusion and model how vapour passes through the building fabric. This gives a reasonable assessment with a comparatively simple process and simplifies data input requirements. However, there are limitations. The main problem is that this method only models moisture vapour flowing from inside to outside and completely ignores the effects of external moisture sources, such as driving rain. The model also does not incorporate the effects of material porosity, moisture absorption and water storage within the building fabric. As is stated in EN 13788, the method assumes built-in water has dried out and does not take account for a number of important physical phenomena. The improved EN 15026 standard addresses these issues with a new calculation method based around dynamic numerical simulation of moisture flows. This type of simulation provides a far more detailed and accurate representation of the way in which moisture both flows and accumulates in the fabric of the buildings. EN 15026 is the method specified for solid walls with internal insulation in BS 5250, making it more appropriate in traditional properties where this type of wall is more common. This more accurate simulation not only allows for greater variations in environmental condition and material properties, but it also offers a more flexible approach to simulation time periods. Designers can look at minute-by-minute predictions on the building performance, taken many years into the future if required. This additional detail and time can often reveal small problems that can grow to cause several issues over the years, issues which would commonly be missed by a simpler Glacier method calculation. The trade-off to using this more advanced method is a more complex simulation software and outputs which are more complex to determine. Here at the A Proctor Group, we use the WFI software package to undertake these calculations. Moving on from this, the energy efficiency of the entire building can be assessed, and PAS 2035 recommends two methods for undertaking this: the SAP or Standard Assessment Procedure Calculations and the Passive House Planning Package, or PHPP. Both of these methods incorporate a wide range of data covering all aspects of the building fabric, orientation and systems, and will give a detailed and comprehensive overview of the pre- and post-upgrade performance. Because these models utilise such a wide cross-section of data, they allow the interactions between various measures to be assessed. For example, the energy performance trade-offs between air leakage rates and insulation levels, and allow variations in levels of insulation in different areas. This is particularly useful as it allows for most aspects of the thermal performance envelope to be traded off against one another. For example, by reducing air leakage to permit thinner insulation in areas with ornate cornicing or restricted space, large rooms can also be insulated to a higher level to retain space in other areas. Although the reduced data or RDSAP calculation method is also available, and indeed was developed for refurbishment scenarios, PAS 2035 is cautious about its use as it makes a number of default assumptions that may not accurately reflect the building under construction. That said, it may be appropriate for use for guidance purposes or to draw quick comparisons between a variety of different measures, provided these assumptions are understood and allowed for. Whichever holistic energy assessment is used, it should be remembered that neither SAP or PHPP account for the effect of upgrade works on moisture, so a separate condensation risk review should also be carried out. This holistic approach to design is well illustrated by figure D1 in PAS 2035, the Measures Interaction Matrix. This provides a simple, at-a-glance overview of the likelihood of incompatibilities and problems arising between various upgrade works. For example, by looking at the matrix, systems which are not appropriate to be used together are highlighted red, such as the combination of decentralized mechanical extract ventilation and heat pumps. Orange interactions, such as those between electric storage heater replacements and heating controls, require additional consideration to ensure compatibility. These may require additional complementary upgrade works. This is also true of yellow measures, such as the combination of upgraded doors and windows and internal or external wall insulation, but to a lesser degree and more related to ensure good detailing and proper installation rather than significant changes to individual specifications. Green areas such as draft proofing and solar PV have little or no interactions or effect on each other and therefore represent a very low-risk combination. The concept of risk in the specification of retrofit is further explained upon in PAS 2035 with the project itself, and individual measures being assigned degrees of risk. Depending on the nature of the project, 3 risk-based pathways are identified, A being the lowest risk and C being the highest. Risk in this context can be considered analogous to complexity. For example, upgrade work to replace the windows of a single house out with conservation areas and of conventional construction will pose very little risk of complexity. By comparison, fitting internal insulation and mechanical ventilation with heat recovery to a listed solid-walled property will be graded much higher. Upgrade measures are also graded 1 to 3, with simple upgrades like draft proofing and hot water cylinder insulation at 1, whereas complex and disruptive measures like ventilation systems and heat pumps graded 3. The higher the identified risk pathway, the more pre-assessment measures are recommended, along with increasingly detailed project specifications and higher qualifications for specifiers and installers. The recommendations in all the areas are extensive, so the PAS 2035 document, along with the accompanying PAS 2030, which covers installation processes, are well worth a read for anyone regularly undertaking retrofit projects, especially at scale. The processes and detailed recommendations are also a useful framework for anyone wishing to understand what is involved in upgrade works, even if the full framework is not being applied to the project. So now let's move on to look at 3 scenarios which commonly pose problems in the refurbishment of older properties, beginning with internal wall insulation. Solid walls, be they brickwork or stonework, are a common feature of older buildings, and often the stone or brick is an inherent feature of the external appearance. This can extend beyond to be a fundamental part of the character of an area. In such areas, even where not explicitly defined as a conservation area or listed building, the application of external insulation systems may not be desirable or practical. Internal wall insulation systems overcome a number of these problems, but typically introduce a few of their own. The main issues that can arise from internal systems are disruption to services and decorative features, and condensation risks. The thickness of the internal insulation system can lead to extensive additional works to relocate switches, sockets, and other services to accommodate the thicker walls, or cause problems if period decorative features such as cornicing may be retained. Insulation systems such as our range of Spacetherm aerogel boards with thicknesses as low as 13 mm for the Spacetherm wall liner can go some way to mitigating this. Because of the exponential nature of U values, even such a thin board can make a significant improvement thermally if no existing insulation is present. However, getting closer to the insulation levels of a modern home will unfortunately necessitate a little disruption, even with such high-performance systems. The other issue, condensation risk, comes in two forms. Firstly, the risk of condensation forming at the interface between the insulation system and the original wall beneath. And secondly, risks arising in any area that cannot be insulated to the same degree as the main part of the wall. In the first case, problems can arise because adding insulation to the wall makes the underlying building fabric colder than it otherwise would be, increasing the likelihood of the dew point occurring in this area. Avoiding this type of problem can generally be accomplished by carrying out hygrothermal analysis using a dynamic simulation over an appropriate time period. By accounting for the moisture storage capacity of the materials and assessing the potential for inward as well as outward drying, this type of simulation can identify the optimum combination of vapour resistance and thermal insulation levels to minimise any negative moisture effects. The inherently permeable Spacetherm and Spacetherm A2 insulation systems offer a variety of thicknesses and can be specified with or without an integrated vapour control layer. This allows both the thermal and vapour resistance to be tailored to the specific project requirements, as assessed via WFI dynamic simulation. In the case of window and door reveals, it's often difficult or impossible to introduce insulation to these areas without compromising the opening size and obstructing the glazed or opening areas. If the majority of the wall area is insulated, but the reveals are not, the warmer surface of the insulated areas is offset by a decrease in the surface temperature where no insulation is present. So, internal wall insulation will actually make an uninsulated reveal colder than it was prior to the upgrade. This reduced surface temperature can give rise to surface condensation at the reveals, a problem only increased by the relatively lower temperature adjacent to the windows. Reducing this condensation can be achieved by adding even a minimal level of thermal insulation, bringing the surface temperature closer to the overall average for the wall surface. Again, the thin, high-performance Spacetherm wall liner system can meet this requirement without unduly encroaching on an opening area. As we discussed earlier, reducing the air leakage of a dwelling is often a more effective route to improving the building's energy performance whilst adding minimal added thickness. How this can be achieved in a retrofit situation is, however, not always straightforward. Applying draft strips to doors and windows or completely replacing doors and windows will go a long way to reducing air leakage. In other situations, such as old floorboard over ventilated solums, or when fitting new internal insulation to a more air-permeable substrate, it's a little more complex to achieve. The principal issue in such situations is how to limit air movement, whilst ensuring no moisture is trapped. Whilst lining the walls and floors with a polyethylene membrane may seem an obvious solution, this can also lead to problems, as such membrane may affect the flow of moisture across the element. As we saw in the dynamic assessment of moisture flow, inward drying and the ability of the building fabric to absorb and release moisture is an important component of maintaining hygrothermal equilibrium. So the challenge is how to introduce an airtight layer without preventing this free flow. In these situations, vapor-permeable air barriers such as our Raptite and Raptherm provide simple and moisture-neutral solution. The membrane is self-adhesive, so it simply bonds onto the existing wall surface, providing an effective air barrier without impeding the movement of moisture vapour in either direction through the wall. The moisture-neutral property of this material means the insulation can then be added without causing a condensation risk, regardless of where in the wall or the floor the insulation and air barrier are placed. This allows for the effective sealing not only of surfaces, but also of junctions, for example, between a timber floor and a stone wall. The Raptherm also adds a high layer of performance, vapor-permeable aerogel insulation to the self-adhesive membrane, providing a highly efficient thermal breaks as well as an air barrier. Because of the moisture vapor permeability of this insulation, it will help minimise moisture and damp problems, not only by permitting drying in any direction, but by also increasing surface temperature and helping reduce any cold spots associated with cold bridging. The final scenario we'll consider here is a re-roof, a daunting project for any building. These can be particularly difficult in traditional or historic properties, which may have a variety of period details and features, as well as less straightforward plan layouts. In roofs with complex geometry or rooms in the roof, it's not always simple to ensure ventilation can provide adequate airflow throughout the entire structure. A lot of existing roofs rely on air movement through leaky fabric with lots of gaps and cracks to ensure moisture vapour can escape, so the lack of condensation problems can be more a case of luck than good design. Such systems cannot always be depended on to perform similarly post-upgrade, particularly if energy performance upgrades substantially alter the hygrothermal characteristics of the building fabric and envelope. Another particular problem is the condition of the existing ceiling, the performance of which may not be known. Some modern roofing membranes require the addition of a vapour control layer, or that the ceiling be well sealed in accordance with BS 9250. And as with the provision of ventilation, this cannot be relied upon without a full replacement of the ceiling, which may not be possible or desirable. Taken together, these two factors make the choice of roof underlay critical in ensuring the roof remains trouble-free after the upgrade works are completed. This is especially true if there's a large amount of wet trades involved in the refurbishment, as this additional moisture load must dry out over the initial heating periods. The critical feature of any underlay used in such work must be the ability to accommodate a wide range of existing situations, without requiring extensive additional enabling works. Particularly in historic or listed properties, getting the outer roof covering removed, any repair work done and the outer covering reinstated in the shortest time possible is paramount. Air and vapour permeable underlays such as Roof Shield do not require any additional ventilation below the underlay, nor do they require any special air or vapour control measure at ceiling level. Being air permeable, air is able to flow in and out across the entire surface of the roof, ensuring the most efficient transfer of moisture vapour possible, even during the initial dry-out phase after completion. This simplicity allows for trouble-free specification and installation on any size and any shape of roof, with minimal changes to the existing building fabric required, meaning the roof can be reinstated as quickly as possible. So that concludes the presentation portion of today's webinar, and we'll now move on to the Q&A session. So that concludes the presentation portion of today's webinar, and we'll now move on to the Q&A session. Good morning, everyone. Welcome to the A. Proctor Group's final webinar of 2020. First of all, I hope you're all doing great. And I just want to thank everyone so much for attending this webinar and our webinars this year. For us, it's been a really challenging year, but these webinars have actually been one of the main constants in the business. And we were so proud last week to have won a Construction Marketing Award for best use of content marketing, which the webinar was our main focus for the entry. So we don't enter a ton of awards ceremonies, but we felt this year was really well deserved. So I was so pleased to see the team recognised for that. So I just want to say congratulations. As you know, we will be here as long as it takes to answer all your questions. I can see some fantastic ones coming through on the live feed just now. So if you have any more, please post them in the chat box. You can also email us at webinar@proctorgroup.com, or you can DM us on Twitter @proctorgroup, as per the on the screen handle there. If you'd like to request a sample pack, a meeting, or anything regarding this webinar, if you go to our website, proctorgroup.com/webinar, you can find all the details and links there to request meetings, to request samples, to download your personalised CPD certificate, and direct you to basically anything you need as a follow-up to this webinar. We do love getting your feedback. I say every time that we read every single comment that we get. And this year, I'm particularly interested in your thoughts for what you'd like to see next year. So we will be continuing these webinars in 2021. So what I'm going to do as a little bit of an incentive is for anyone that does put feedback to this webinar or our webinars this year with some ideas for next year, that what you'd like to see, and will be entered into a competition, and you'll get a fabulous Christmas hamper. So the winner will be picked out at random. So after you receive a follow-up email, please fill it out, send us back some information, critique what we've done so far, give us some ideas what we may be able to do next year, and we'll send out a great Christmas hamper. So send those and get them into us by the end of play Monday, and we'll pick it out at random, or I will on Tuesday. On webinars, our next one is going to be Friday the 29th of January. So the topic for our first webinar of 2021 is the physics and applications of construction membranes. The registration is now open, so that page I was talking about, that you can go and request information and all you need, you can go there now and register for the 29th of January 2021. It really helps us if you give us a thumbs up on the video here, and you can also subscribe to our YouTube channel. So just talking of YouTube channels, we have a very interesting guest today. Tim and Joe, well, we only have Tim today, but they are essentially the restoration couple. So believe it or not, they have a YouTube channel with, I believe, over 100,000 subscribers. So if you haven't, please check that out, the restoration couple. So Tim and Joe are a couple who have been renovating their own period home over the last 7 years. So basically, they've been sharing this journey and all their tips on Instagram and their YouTube channel. So the real emphasis, I think, has been, Tim, and I'm sure you go into a bit more detail as you answer some questions, but it's been to make sort of an older, inefficient home into a real suitable home for modern day living. So kind of the balance between retaining the original characters and features, which is something we talked about in the webinar, and making sure that it's as efficient as possible. So a bit of a balancing act. So good morning, Tim.
Good morning. Thanks for having me.
You're very welcome. Thank you for coming. And some familiar faces before we go into the Q&A. We have Adam Salt, who is our Southwest-based Technical Regional Sales Manager. Morning, Adam.
Keira, morning, everyone.
Good morning. James Brackenreid-Johnson. Sorry, James, I called you Jones before. I'll never forget that now. James Brackenreid-Johnson, who is our London-based Specification Manager.
Morning, Keira. Morning, everyone.
And Pamela Howitt, who is our Senior Technical Advisor based up in Blairgowrie.
Morning, everyone.
Good morning. So Pam, if you don't mind, I'm going to start with you. Just a question that came up regarding, well, it wasn't a question actually, it was a comment. Now, I'm sure that our technical team are using the most up-to-date version of the BRE calculator that complies with BR443, but seeing as you are a technical advisor, can you just confirm there was a comment on the YouTube feed regarding that?
Yeah, sure. I'll need to go back and check the date on that one, but yeah, certainly the ones that we use for producing calculations to send out to interested customers and parties is the most up-to-date version that we're aware of. So we check version histories, we check for updates on a regular basis, but I will take that on board and I will contact them and just double check that to be sure. But as far as we're aware, we're using the most up-to-date version.
Yeah, we're quite diligent, so I would like to say it's a screenshot from marketing, so we'll blame them. They've just received an award last week, so they can take a little bit. Great, so I'm just going to go ahead with the questions, and as I say, if you have any more, please post away or send them via email. So again, Pam, I'll just come to you for the first one for Simon. From Simon, what effects do drafts have on the house?
It's a really good one, says she's sitting in a drafty old room. I mean, the biggest one is basically it takes away your heat. So you've spent all your hard-earned money heating up your building, and by too many drafts, you're either diluting your heat with cold air coming in or basically sucking it right out of your building. So really, to address your drafts and to improve those is one of the easiest and most cost-effective upgrades that you can do. So things like good draft excluders and seals around your doors, your windows. Consider updating your windows if you've got particularly drafty single glazed windows. We have them here, but the difference or even putting shutters, we have shutters that when we close them at night, it makes a huge difference to the temperature in the room. Look at pipes, you open up kitchen cupboards, quite often it's really drafty under there. That's because the pipe has maybe been cut and not sealed as well as it should be. So things like that are going to make a huge difference. And things like our Raptite tape, you can use that to seal around the perimeter of your wall. We've actually got a data sheet on that. If anybody wants it, ping the technical team an email and we can send it out. So you can actually wrap that at the junction between your floor and your wall, behind your skirting board and under your carpet, and that will help prevent anything. But the benefit is, because it's Raptite, you're not going to cause any issues with moisture being trapped, etc.
Okay, great, because that was the question actually that Tony had asked, and that I was going to come to. Would Raptherm and Raptite located internally trap any moisture in the external wall without continuous ventilation gaps?
No, it shouldn't do, because the Raptite component is vapor permeable. It is in essence sort of vapor neutral. It's not going to hold moisture in your building. You've not got the same risk that if you put like a vapor control, like a polythene on the wrong side of the insulation, you could have serious issues. So because it's permeable, it's breathable, it's not going to cause any issues.
Okay, good.
Any sort, we can assess any build up just to be sure as well.
Well, Pam, actually, I'm sorry for asking so many in the beginning, but another one that's kind of on this train that we're talking about, which I'm skipping a few and I'll come back to them. So Jonathan has asked, what about assessing the moisture storage capacity of a wall to avoid condensation when an existing wall is to be upgraded? So I guess how do you actually assess that?
Yeah, so I mean, there's two things that we can do. So it depends on the wall construction. So if it's a solid wall, that's going to be more moisture sensitive than something like a cavity wall, because of that void there. But they can all be assessed either by the sort of standard Glacier method, or where it's a more sensitive application, we can look at it with the WIFI, the hygrothermal assessment. So we can look at whether that wall has perhaps had an issue with a leaky pipe on the outside, so we can put in moisture beforehand, and we can assess that a lot more carefully, tweak the amount of insulation that's used. So the Glacier is a really good one to get an indication, followed on with something like the WIFI software to actually assess a more in-depth risk.
Okay, brilliant. Thank you, Pam. Adam, okay, if I can come to you. Linda has asked, what are the advantages of using an HR underlay compared to an LR underlay?
Okay, so HR is high resistance underlays and LR is low resistance. So when we look at the BS 5250, high HR underlays are defined as having vapor resistance greater than 0.25 meganewton seconds per gram. And LR underlays have a vapor resistance less than the 0.25 meganewtons per second per gram. Now, HR underlays will therefore require ventilation, and LR underlays may not require ventilation. An important word there is may, because when we start looking into the data sheets and the third-party certifications, we can start to see some differences between these membranes. Not all of them are the same. And I'm going to do another bubbler demonstration. So we have a membrane in here, which is an LR underlay, class W1, so it's resisting the water. That's in the top chamber, and the bottom chamber we just pump air into, and what we see is no air movement through that membrane. And then when we take a membrane such as Roof Shield, which is air permeable and low resistance, again resisting the water that's in the top chamber, but when we pump air into the bottom chamber, we start to see the air movement through the membrane. So it's very important to understand that not all membranes are the same, but because of the sort of air permeabilities and low resistance, we can start to remove ventilation at eaves and ridge level. We can start to remove your vapor control layers from your build. We also have benefits with roof shields, such as in warm roof scenarios, the insulation can touch the back of the membrane. We don't suffer from that tenting experience where moisture falls through, so you can put more insulation between your rafters. But yeah, with sort of any sort of those projects, and you're looking to do your own, in particular, come to us, such as Tim did, and I'm sure Tim can describe how he found Roof Shield on his project quite well.
Yeah, really good actually, and it's, some of it's still visible because I'm not quite finished yet. But yeah, all went to plan. Really, every roofer I spoke to was kind of either using it already, or everywhere I went I could see a green roof. So that's kind of how I started out. And then obviously after speaking to you guys, just that idea that it was reducing the risks a little bit, because what I don't want to do is end up with issues a few years down the line. So the insulation I put in between my rafters, I'd aimed to leave that 50mm gap, which other membranes, would require. But actually, even extending my rafters inside, that was less than 50. So as soon as I heard that it was possible to use a membrane that didn't, I could probably at about 30mm, 25mm. So there's still a little bit of a gap there, but that risk of needing complete airflow over the top and all those little blockages where I stuff things into the loft and there might be then a cold spot with no airflow, and so it was more about, it just seemed like a really good way of minimizing any risk up top, and I don't really want to be up there again.
Good. And Tim, can you, this has come through via email from John. What influenced your choice of products that you used in these refurbishment works? Can you talk us and our viewers through that?
As far as the roof, or just in general?
The whole thing, I think. I mean, obviously the roof would be great, but I mean, just in general, how did you go around choosing all the different materials you used throughout your upgrades?
So basically, I normally look at the house, how it's behaved over the last 100 years or so, and then see how, what am I going to do that's going to ruin it? Because, if you look at it 20 years ago, 30 years ago, even this house was just plastered with gypsum, and, all these things, we were kind of causing our own problems, in previous generations. So I thought, well, how was it built? How did it work originally? And that's all about, it's always been breathable. It's always had lime mortars and things like that. So the idea to just stick, foil backed insulation against every external wall was just something I really wanted to avoid. But, on the balancing act, you still want to create a warm home. So it's always been that sort of risk versus benefit sort of thing for us. But as far as the stages that we did things, I think we just went for all the low hanging fruit first. So it was all the draft proofing, the light bulbs, it's all that really easy stuff. And anytime anyone talks to us about moving into an older home, they normally come to us and ask, would you do an air source heat pump or passive house conversion? And actually my first thing is, don't worry about, triple glazed windows. It's all those little bits that you can get in and do within weekends. And that was always our priority. And then you can build on that. So I guess, yeah, it's always been about low risk, and not just going for the quick and easy fix that many people do in retrofits.
Mm-hmm. I like that. So sort of bite-sized chunks. So don't try and do everything or huge things at once.
I mean, because you might realize that actually, a month later, you might start spotting things. You're actually working in a slow DIY route sometimes has its benefits, because you can spot, little bits of condensation for me. We just had a little junction when we insulated some suspended floors, and all it was just our new wooden subfloor was just touching through a membrane, through some membrane, but it was touching the stonework, and it was just enough for a cold bridge. So there was no leak or anything, but it was enough for that tiny spot of board to get cold enough, and there was just a little dew point there. So we wouldn't have spotted that if we crashed in 1 week and just done it all, and it would have been there, rotting away, I guess. So sometimes slow's better.
Yeah, absolutely. Thanks, Tim. James, if I can come to you for a question, please. Cora has asked, can Raptherm be used externally?
Great question. Yes, it can. Obviously, the Raptitherm product consists of two products, one being Raptite, which is used on external sheathing boards. It's watertight W1, vapor permeable, and airtight. So therefore, what we're looking at with that, you've got the Space Therm or Slentex. So you've either got a more high-performing aerogel product or an A2 rated aerogel product, which is bonded to that Raptitherm product. So you've still got the vapor permeability, but you've got the air tightness and water tightness there as well. So you've got the external airtight line. The aerogel product as well is hydrophobic in nature, so naturally repels water. So the performance of the insulation won't be impeded by the fact that it has water on it at all. But ultimately, what you've got to look at before installing anything on the outside is the condition of the material that you're putting the product onto. So in regards to an external brickwork, obviously, presumably you won't be overlaying any attractive, aesthetically pleasing stonework, but still you need to look at that brickwork and improve or repair the mortar joints. If there's any growth within the mortar joints, please have a look at that and make sure that that's all dealt with prior to. Again, the product is self-adhered, so it will bond back to that brickwork. So as good as that brickwork is, if it needs to be infilled with cement, please do so. Again, look at as Tim mentioned, in regards to looking at the actual material that the mortar is made of. So if it's a lime mortar instead of a standard modern material, then please make sure that you're aware of that, because obviously with the material, you're not going to be stopping that vapor drive through the building. And in regards to overcladding it with the material, then obviously there's a plethora of different facade finishes that are out there.
Okay.
What does need to be taken in consideration as well is any of the vents, pipework or bracketry that's going to be mechanically fixed through that. So you reduce down the amount of cold bridging that is potentially going through there. And depending upon what type of aesthetic finishes of the property, the bracket type and again, the fixings need to be addressed to reduce down that impact.
Okay, great. Thank you, James. And Elizabeth has asked on the YouTube feed, this one's about substrate preparation. I'll just read these questions out. With Raptite installing in traditional buildings, as they have the self-adhesive backing, so does the wall need to be prepared? And if it's applied to a wall, can it be removed in the future? And if walls are damp, can that membrane still be applied? So one around the preparation of the internal wall, I'm presuming, and also can we remove it in future?
Yes, I mean, in regards to internal walls, obviously there's a multitude of different buildings out there. Some have been around for quite a while. So if there's a painted internal wall, then there may be decades of paintwork that are on there. Ultimately, if you're dealing with a solid wall system, you've got, as Tim mentioned earlier, you need to treat that building as how it was built. So it's a vapor permeable system. But ultimately, if your goal is to thermally improve that building and you've got no issues with condensation currently within that build-up, then utilising the thinner insulants in order to improve the thermal value of the wall build-up outweighs obviously the vapor permeability. But you're still maintaining that internal usable space, optimising, I should say, that internal usable space by utilising a thinner insulant. In regards to externally, with Raptite, if the substrate is damp, there is obviously the drier the better, but because of the nature of the material, because it's vapor permeable, what you're doing is you won't be trapping that moisture. It will still be able to vent through the system, so that moisture will dry out. But again, when you're looking at a solid wall system, you're looking at the porosity, absorption and retention of that solid wall system. So where you've got the internal insulant going into the building, you're automatically, because you're putting that insulation internally, you're therefore cooling down that internal face of that blockwork or brickwork. So therefore the ability of moisture to ingress further into that external wall envelope will be increased. So therefore, again, you need to make sure from an external point of view, the mortar joints, the brickwork, the blockwork is of a good working order, because obviously you don't want more and more moisture getting into that brickwork or blockwork because of freeze thaw, which can structurally damage your building at the end of the day. In regards to removing the Raptite, It can be removed, not very well, because of obviously the nature of it being adhered to the substrate for a permanent basis. But I don't know if Pam's got an answer for that one.
Yeah, it's probably with something like a stone substrate, it's definitely more feasible to remove it from that for future, simply because stone surfaces aren't as regular as something like a sheathing board, for example. So therefore, you will get a little bit of spalling from the face of it. So, just like a dusting of sand. And because you won't have every single part of the adhesive bonded to every single part of the wall, it certainly it is more feasible to be able to remove that from a brick wall than it might be from some other substrate.
Yeah, it's probably worth noting, I mean, this material is meant to be used over many, many years. So the nature of the adhesive, not only is it very specialist in terms of its breathability, but the actual properties that the adhesive has in it, this stuff goes on the external concrete walls in high rise, and it's meant to stay there. Really, I don't think we have had anyone, we have removed it in trials ourselves, but really it's meant to be there for the
Absolutely.
Okay.
Because it's, again, to reiterate this vapor neutral nature, it shouldn't be causing condensation issues if used with the right build-up.
Okay, great. And Jane, just quickly while we're talking about substrates, Toby has sent via email, just anything additional you can add here, any consideration for fixings that may penetrate the wrap internally. So how do you account for long-term use without creating detrimental damage to the wrap? So in terms of when it's applied on an internal point of view, is there anything you need to consider about that?
Sealing around the heads of the penetrations, in all honesty, I mean, everything's about pre-planning. As I've said about substrates, it's about understanding that substrate. It's about understanding the build-up of the property that you're looking at. So if you're planning to fix in a particular way, if you know where your battens are going, we have a product, obviously, which we utilize alongside with Raptite, which is called liquid flashing, which can be placed where you're putting your fixings through, which will seal around that. And again, the product is basically a liquid Raptite, so it's a moisture tight, vapor permeable, and airtight. So it will take around the head of those, around the thread of the fixings and around the head of the fixings if you require, and therefore seal it that way. So at the end of the day, if you're planning to do any mechanical fixings through the wall, if you're using a batten system, if you're not offsetting that wall, if you're fixing directly through that substrate, then just make sure you've got the liquid flashing to hand where you're going to be mechanically fixing, plan it out, and then put a dollop of the liquid flashing on there so that when you fix through, it will seal that product in. So you get that air tightness layer.
That's the technical term. Put a dollop on. No, I'm
sorry, it was a bit off the cuff, but yeah.
No, you're
a small amount of the liquid flashing on there.
Yeah. No, you're spot on, James. I'm just okay, thank you very much for that. And Adam, I've got a good question here for you. It's quite a general one. What option is better for solid walls? This is from Amir. Sorry, internal wall insulation or external wall insulation?
Okay. Yeah. So, I mean, a lot of people at the moment are looking at improving their properties by insulating them for improving the comfort reasons, also to reduce the heating costs, and also to reduce your CO2 emissions. So when you start looking at your project, you go, well, I can go internally with my insulation, or I can go externally. And comparing the two, well, if we start with the external wall insulation, then the simpler method for removing thermal bridging, as you're wrapping the external of that building in insulation, whereas internally it's a little bit more difficult to deal with all those thermal bridging areas. So external is the benefit there. External insulating can, in some cases, improve the appearance of the building as well. Bristol, where I sort of grew up, is known for having loads of brightly coloured buildings from where they've all been externally insulated and recladded. So yeah, a lot of buildings can be improved, but the issue where external insulation comes in is where we're looking at these properties with beautiful external features, such as in Bath with Georgian Properties. Tim might know in his area as well, down in Swindon. And you don't want to be covering up that beautiful Bath stone and features with an external system. And in the UK, we have a huge proportion of our properties where they are old and full of character, to make external insulating not an option. Therefore, that leads us to looking at internal options, and we're left with a few challenges. Breathability has been discussed by Tim and James. We want breathable insulations to reduce moisture, to allow that moisture pass through the walls, thus avoiding any possibility of interstitial condensation. But breathable insulations typically have poor thermal performance compared to your rigid ones, such as PU insulations on the market. So you need a great thickness. And one thing we also struggle with in this country is space. So, losing potentially 200 mil on every wall internally. I mean, if you look around your own rooms now, that'd make your room a lot more snug. So it becomes quite difficult. But we obviously have Space Firm, which is an ultra low thermal conductivity. And that means we can reduce the thickness massively and improve your thermal performance, as well as also being breathable. So yeah, we can benefit there using Space Firm, those sort of projects. But really, going external, internal, you've got to look at, when you use internal insulation, you've got a higher thermal mass externally. And when you use external insulation, you've got a higher thermal mass internally. So what that means is, when you use internal insulation, you get a quicker response from your heating. So perfect for the people that are in and out of the house all day. If you're out of work, then you come home for a little bit, have some dinner, then you pop out for the evening, then you come back for a little bit, then go out for work again. So internal insulation is great for that, because your response from your heating works a lot quicker. But obviously, when it finishes, it gets cooler quite quickly. But when you use external insulation, the property can take a lot longer to warm up, but it also retains that heat when the heating turns off. So if you're like myself, who works from home all day, better to have a sort of an external system where you're going to not have the heating on full blast all the time on that. So yeah, you've got to weigh up your projects, but that's what we're here for, really. Yeah,
good.
Hope that's answered that.
Well, thank you, Adam. Really in-depth reply there. Appreciate it.
Right.
I'm going to ask you one here and then come on to a couple of ones about roofing that are in the chat feed. So one we've had via email, first of all, just when we're talking about glazing and insulation. Lynn has said, I'm looking to replace the glazing and add insulation to my property. Is there anything I need to watch out for?
Yeah, I'll take that one. Yeah, it's a really great question, because so often we do work to our building without really giving proper consideration. That sort of harks back to what Tim said earlier on as well. It's we sort of go straight in and let's do a deep refurb and let's put triple glazing in, let's insulate everything up as much as we can. Let's block up the chimneys, get rid of all the gaps in the joints, fill that up with squishy foam. And sometimes you can start building up really, really severe issues if you don't look at the right balance of everything within the building. So, we've touched on that sort of EWI benefits over IWI. So if you warm up on the outside, it's touched on as well in the presentation with the sort of the wall showing building up moisture. External insulation is obviously going to keep that wall warmer, so it's less of an issue. So if you really wanted to go deep refit and really high levels of thermal, you would really need to look at it outside, but that's just not possible for so many of us. So your IWI needs to be balanced. So sometimes you do have to make that trade-off between the amount of insulation you use and the permeability. And it's not just from the amount of space that you're losing, it's actually for the health and well-being of your wall. You don't want to overload it with moisture. There are some webinars in our Learning Hub that actually go into that in a lot more detail than we have time for here, so I recommend them to you. So things like blocking up the drafts, which I talked about yesterday, sort of filling up a chimney and blocking it off, it's great, it doesn't draft, but all of a sudden you've taken away air movement and ventilation, natural ventilation that you had. Okay, it might be uncontrolled ventilation, but you need to consider putting things like that back in. So making sure that you have adequate and working vents in your kitchens and your bathrooms, and that you use them. And that if you've updated your windows, you know, get your trickle vents open, use them. If you don't, you could end up having quite a lot of moisture stored up in your building, which then can find those bits that are cold and start condensing. Also things like, you know, we don't always think about it, but check your downpipes, check your roof flashings, check your gutters. Make sure all of these things are fit. You know, if you've got a slip slate, get it repaired. You know, this all introduces moisture to the building, which can be very detrimental to the fabric of the building and undo some of the hard work that you've done in insulating it up.
Okay, great. Now, Pam, these couple of ones regarding roofing. Let me just find. Sorry, we're getting a lot of great questions today, so this is great. Keep them coming. We will stay on and answer all of them. One from Jamie: is the Raptite system applicable to your roof in the same way roof shield is? I.e., we can wrap a timber frame or light steel frame building in Raptite rather than having two products.
Yeah, absolutely. Where Raptite is ideal to be used on the roof is where you've got a completely warm structure. So you've got your insulation following the pitch of your roof from eaves to ridge, because the Raptite needs something to bond onto. So you wouldn't normally put it over an open rafter. So if you've got a warm fabric, so basically your insulation following the shape of your building, wrap it in Raptite, cover it over. It's vapor permeable enough to be used in a roof and compliant with BS 5250. So yeah, by all means, wrap it all. It's brilliant. It does a really, really good job of providing your air tightness line on the roof and wall as well.
It does. It's in my roof and walls. Will add. So, and sorry, one that I missed a bit earlier from Gavin. If using roof shield in conjunction with a metal tile formed sheet, is there still no need for any form of ventilation?
It's a really great one, actually. As much as we promote roof shield as being brilliant, there are some exceptions. And actually, this is one of those exceptions, but it's not a function of the roof shield. So what you need to do is the roof shield will still allow the vapor to pass out of your building. But if you then have a layer above that, that's stopping that, so metal sheet tiles, maybe some of the very close fitting, very smooth man-made fibre cement slates, they can sometimes be considered not air permeable enough. So that means that there's not enough gaps between them for that vapor to dissipate out through. If that is the situation, and that is a function of the tile manufacturer to test and ascertain, if that is the case, then you will need to consider ventilation to the batten cavity. So this isn't below the membrane, this is between the membrane and the outer tile. So yeah, give us a call if you've got any specifics, or check with your supplier of your metal tiles, because generally if their systems need ventilation, they will have a solution for it. But it doesn't make any influence on how the roof shield functions.
Okay, good. And last one, we've almost kind of covered this, but Ian has asked, if you have a void above the roof insulation between rafters, which technically needs ventilation at eaves and ridge,
yeah,
can you emit the vents if you use a breathable membrane? So I guess you can answer that in terms of breathable membranes and roof shield.
Yeah, absolutely. I mean, Tim mentioned one of the reasons he went for roof shield was because he didn't need to worry about keeping and maintaining that 50 mil gap. Adam's touched on it as well. Very different. I mean, you have the low resistance underlays, which are airtight, and then you have the air permeable low resistant underlays like roof shield. So it's not always the case that you can emit the ventilation to that gap if you're using a different type of membrane, i.e. a non-air permeable product. So certainly with roof shield being the air permeable nature of it, it's an additional mechanism for vapor to move out your roof. And therefore you don't need to have that clear 50 mil void, which allows you again to put more insulation into those rafters, make your roof more energy efficient. Especially important where you've got small rafters and you maybe can't accommodate a lot of insulation. So yeah, it's not the case with all membranes, but it is the case with the roof shield membrane.
I think, Tim, did you have e-vents originally designed?
Yeah, so originally, when we obviously had the original roof here, there was no membranes. It was just the slates that had been on for 120 years. There was just a great big bird-sized gap all the way along the eaves, which was giving the ventilation. So I immediately thought, oh well, I'm going to scribe my new soffit in, make it all neat, but I'm going to have to put vents in. So I ordered these. I've still got a box of the 25mm vents to go over the top of the fascia. And then it was, it came to talking to you guys, and then it worked out that they weren't needed. There is a little bit of a gap just where it's scribed to the stonework underneath. So I guess there's a little bit of airflow, which is no bad thing. But it was nice to not have to, worry about all that, because that's going to change the fascia height and the gutter height, putting in all that ventilation. And also I didn't need to drill any holes to have, big soffit vents, which in a traditional look, when we were going for painted timber, just wouldn't have worked. So yeah, that was kind of a big plus for us.
Great. Perfect. Right, Tim, seeing as you're speaking, I've got another question for you, which is coming through the email. I don't actually know your background, if it was construction. That's a question for me, sorry. Do you have a history in construction at all? Or is this
No, just a keen DIY. No, I work in construction a little bit in that I'm a photographer, so I work on for architects and construction companies. So I kind of soak in a little bit of as I'm walking around commercial and domestic sites, but no, it's all just kind of self-taught DIY. So no certifications here.
Right, okay. Well, this is a good question then. So Lily has asked, you're obviously a competent DIYer. How are you finding it carrying out your own work?
I think, well, like I said, it's kind of been a learning process. So little bits, build it up. And I always say to people who are kind of starting out on DIY, just build a shed first, and then, it might be convert your garage. You start getting an idea of how insulation works, and there might be a small amount of extending wiring and getting in electricians, and and then that's a mini project. Then it might be an extension, and then so that's kind of how I always suggest people kind of work their way up. But the roof was certainly, in hindsight, probably a little bit too much for a solo job. So I'm kind of on, I think, my 9th week now. And it's a big old roof, but it would be a good one to tick off the bucket list anyway. I'm not sure I'd do too many on my own again, but yeah, I mean, it was quite a daunting one, but I think getting all the research done beforehand, talking to other roofers who kind of just know this stuff inside out, talking to manufacturers, whether it's people like yourselves, about the actual way the roof's going to work as far as vapor and insulation, but also looking back at all the way it was for the last 100 years. There's been painted softwood up there, and 90% of it was just rock solid still, so there was no point in putting like plastic or aluminium fascias and stuff up there when I've got a proven track record kind of on top of the house already. So a lot of it we replicated rather than trying to reinvent the wheel. But yeah, that's kind of just learning from the building itself. Just as you pick away at a wall, you kind of see how they've done the lime plaster or the laths on the wall, and it all makes sense. They weren't stupid, the Victorians.
Very good. Thank you very much, Tim. Coming on to the sort of last 4 or 5 questions, and I'll make sure I just go back through the YouTube feed as well, and the emails. So this is our last webinar. I'm sure I'm not going to miss any today, because at the end of every webinar I come across one and I'm like, oh, can't believe we didn't catch that one. So I will go through and check. But James, Paul has asked an interesting question. Can you deal with commercial change of use projects?
Yes, obviously it's something it's coming up a lot more often than what it used to, with commercial buildings which are being stripped back and converted into residential apartments mainly. So whether it's a concrete frame with infill, whether it's got a curtain walling system being put on the outside, whether it's the existing system being stripped back to a certain layer, and then new products added to bring up to regulation, so to speak, whether it be thermal, whether it be fire. We can sort of get involved with those with the membranes, some of which we've discussed already. But obviously, whatever project you've got, we're more than happy to discuss with you. Obviously, the build up, whether it's off-site panels brought in and then bolted on, or whether it's a metal frame system. I nearly mentioned a company's name there, whether it's a metal frame system that's used as an infill, then we've dealt with all of those sort of systems before, so more than happy to get involved, put the systems in, do the U-value calculations, do the condensation risks, and we can go from there. What we found, apart from the facade of the building and apart from the roof of the building, a lot of the errors that are made, or a lot of the things that are overlooked, is especially on the acoustic side of things. Because obviously the regulation for commercial to residential is very different in regards to acoustics. So therefore the flooring systems, again, whether it's leveling, whether it's acoustics, do need to be addressed. And that's something obviously we can assist with as well. We do have a range of those, of the acoustic and leveling products available, not on the walling side, but on the floor side of things. So if you've got a plan of what you're looking at doing, or if you need some sort of advice on what sort of products go where, then obviously we can assist in regards to that. And obviously from a design perspective, we can advise on which products to use, depending upon the parameters of the job.
Okay, great. And Jodie has asked, how would you externally approach a timber frame?
From obviously the vein of what we're talking about today in regards to retrofit, what I would say is projects such as what we're dealing with at the moment, we're taking back that facade to the sheathing board. And just like with what I mentioned before about substrate preparation, it's making sure that that substrate is up to a certain standard, because obviously the install that you're putting in over the top will be as good as what the preparation is done underneath. So if that sheathing board, predominantly going to be OSB or ply, needs to be replaced, has got water damage, once you take that, once you core out what has been damaged, once you take off those boards that are damaged, you may find that there's the insulation's damaged as well. So if you just negated to look at that sheathing board, or just say, well, it's still there, that's fine, we'll just overlay it, you may be compounding a condensation or moisture problem by overlaying the products with new products, and therefore the moisture is still in the system. So it's well worth understanding exactly what's going on within that build-up. But from our point of view, especially in regards to timber frame, if you look at the fire shield product that we have, which is a very high-performing Class B S1D0 intumescent graphite-faced product, please have a look at that. We've got videos on our website. Due to the constrictions of ratings in regards to classification of membranes, it is still classified as a Class B S1D0. We believe as a company, I may get my wings clipped for that one, but we believe as a company it should have an enhanced fire spread retarding classification. But ultimately, at this moment in time, it's Class B S1D0. But please have a look at the reaction to fire that our product has. And especially from a timber frame point of view, if you look at proximity to neighbouring buildings during construction, if you look at the effects and the way that it can work complementary with a non-combustible, with a cementitious cladding system. Obviously, there's a lot of buildings out there at the moment which have a timber clad on there. And those are periodically being stripped back and replaced with cementitious cladding, which obviously is a faux timber, looks like timber, but is actually cementitious and non-combustible. And having this complementary product behind it as a breather membrane is really worthwhile installing. And we're working on projects in that vein at this moment in time. So stripping off back to the sheathing board, replacing that sheathing board if required, and then putting back on with the fire shield and then with the non-combustible batten and cladding system.
Can I just jump in there slightly and just to reiterate a point that James has said? The key benefit of the fire shield is that that's a Class B, and we have that test data on OSB timber and particle board. So it's not just a Class B on a non-combustible sheathing, it's a Class B on a timber substrate.
Great point. None of these asterisks.
Yeah,
No, that's a great point. Thank you, James and Pam. And I think it's quite amazing. I mean, if you do go and have time to look at that video, which compares two Class B materials in terms of our fire shield and another, and how they perform in situ. I was actually there for the test that day before lockdown. It's unbelievable to actually see how these materials perform when they're ignited. And we have a lot of materials that are Class B, and again, our materials perform differently when ignited, although they're in that same
bracket. Yeah,
in the same bracket, absolutely. So more work needs to be done, I think, to help categorize these materials. Okay, great. I have one here via email, which I don't want to miss. Let's have a look. So, Pam, if I can ask you this, please. Rob has asked, when assessing the suitability of materials and systems for refurbishment, do the assessments take into account the possibility that the refurbished property may suffer from overheating?
Overheating is, yeah, I mean, it's a really good one, that one, actually. Overheating can be, it's not something we actually suffer much over up here in Scotland, but certainly the software that we utilise doesn't really go into overheating. It really just looks at how that heat internally and externally will influence the movement of the moisture through the building and the ability for it to dry it and reach equilibrium. But definitely things like insulating too much is going to affect, affect overheating. So your external wall insulation, for example, is certainly going to prevent your building heating up as quickly because it's acting as that buffer. But it could actually work in the other way if you don't have a way of purging that heat at night, like opening windows and having ventilation. You could struggle with your building retaining heat too long. That's one of the plus points about solid stone buildings without any heating. Insulation in them is that they stay lovely and cool during the summer. So it's that mass there can work both ways. Mm. So external probably helps better than internal. Looking at shading on windows, making sure that you have proper trickle vents to allow the movement. Even things like you get coatings for glazing now that help to mitigate against thermal gains. So you do have to look at it, and you probably would need to engage the specialist advice of somebody that can do more on the overheating calculations. That's more looking in at your M&E, your sort of mechanical engineers and things like that can look at the ventilation strategy, etc. But yeah, it's definitely an issue that's becoming more and more prevalent from sort of Birmingham south. Is that overheating is a real issue and something that we do need to look at and tackle, and is something in our R&D wish list for the future as well. So
it's on the agenda, and as you say, it is a topic that we're certainly being asked more and more about. And well, even when we were building this house, you mentioned shading there. We had to be careful. You can see there's a lot of glass in this whole house. So you obviously choose the type of glass carefully, but when it comes to the shading and certainly the orientation of how we place the building, even up here in Scotland, we had to take that into consideration. Yeah, where is going to receive the sunshine, and we do quite big overhangs to make sure so we don't suffer from that, luckily. But
exactly. I mean, the orientation, you don't realise just how much influence that has on your building. So don't put your big glazed wall facing south unless you want to cook inside.
Yeah, oh absolutely. And you hear some horror stories of people that have done new builds and not taken these into consideration. But I guess it's less of an issue with refurbishment anyway.
Absolutely.
Probably by the nature of these buildings generally. But it's a good question, so thanks for asking.
Good question.
Right, just coming on to the last few. This has been a fantastic session. This one, Adam, is probably you do have an awful lot of contractors and roof shield users in your area. So Tony's asked, do we have a list of improved installers who understand the subtleties of using LR breather membranes in the external envelope? There's not really approved installers, is there? But what you have is kind of more educated installers, roofing contractors, etc. Would you say?
Yeah, I think that's right. I think as Tim mentioned earlier, in the southwest region, there is green roofs everywhere. It's the sort of tried and tested product down here. And yeah, a lot of general trade, Tim, who had no experience, managed to install it. So if you do your research, potentially you can install it yourselves. But yeah, there's no sort of specialist required. But you need to have the background knowledge of what you're doing, which a lot of general trade roofers will have. And that's another thing with Roof Shield as well, that it makes it simple. There's so many products out there that on paper are fantastic, but when you start putting them in on site and being installed, they're very difficult and hard to achieve what they're designed for. whereas Roof Shield makes it a lot simpler. So, you don't have to worry about installing vents, vapor control layers. You are literally just putting a membrane over the top of the roof. So there's another benefit as well on that.
I'll just clarify, when Adam says green roofs, he means Roof Shield green, not actual green. We all know Roof Shield green, of course, but it is a very green coloured roofing membrane. So, I think as well, probably a lot of roofing contractors, they are quite well educated in terms of the use of these types of materials. Now, of course, there'll be some there that aren't, and will use whatever membrane, because there's hundreds of membranes on the market. But what we find is that the contractors that certainly are aware of Roof Shield and use Roof Shield, they really know the benefits of using the product, and the lack of issues that they have with it, and the air permeability, and they're quite advocates of the product actually. And some of our biggest house builder customers, for example, were introduced to us through a roofing contractor who liked Roof Shield, so they're kind of good supporters of the product. So I'm quite well versed in how it works. Okay, great. So last question or two, but one for you, Adam, and I think one for you, Pam, and then we'll come back to Tim before we say cheerio, if that's okay. So just very quickly, Adam, one about vapor control layers. Can you just go through what type of vapor control layer may be best for retrofitting Colin's project?
Okay. Well, we have a number of vapor control layers. Good chance to get my hand principal brochure out. But yeah, we have a number of vapor control layers, and really it depends what you're trying to achieve with your project, to which one you're going to use. If you take our ProTech FR200 and our ProTech A2, they're for projects where you're looking for a fire rating from that VCL. But talking for domestic, we are typically classing those type of buildings as medium risk projects. So that would be our reinforced ProTech 500 normally, for those sort of types of buildings, compared to if you're looking at commercial factory buildings, you probably wouldn't need as high a performance as the ProTech 500. So domestic, that one. But really, I suppose our most suitable one would be our ProTech Adapt. And the ProTech Adapt is a VCL that has a variable permeability. And how that variable permeability works is it adapts to changes in humidity levels, becoming more resistant in the winter and more permeable in the summer. So in the summer, the building fabric is allowed to dry out more effectively, and in the winter or colder months, the membrane protects the building fabric from any damaging moisture levels. I think Ian Fairlington, and I've mentioned in previous webinars, likes to describe it as similar to cells on our skin, the way they sort of open and close depending on the sort of temperature. But yeah, because of that, the Adapt has a wide range of SD values and guarantees the performance throughout damaging climate conditions, and is a dynamic membrane compared to other VCLs where they are more static. That's probably the best sort of membrane to use for those projects. And get the best for your building.
Absolutely, I'd agree. Pam, quick one for you, which was about cold bridging. If I can just find this. Yeah, so this was Julie. So basically she said she has lots of insulation in her project, but she's read about cold bridging. Is it important? So I think what she's trying to say is if she's insulating major wall areas, and we did cover this a bit in the webinar, with insulation, how important really is the cold bridging?
Yeah, I mean, a lot of people think that, oh, it's fine, I can just disregard it because I've whacked 200 mil in the walls. But actually, it can have a huge impact. I mean, window reveals, depending on the depth of your wall, can be quite a sizable area not to insulate, so it really shouldn't be ignored. There was some research carried out, as far back as 2013 by what was then the Department of Energy and Climate Change, and it showed that actually emitting the details and the insulation at the reveals could have a quite a large effect, and certainly one that was greater than we actually assumed. It's also the spot where you're likely to get things like black mold occurring, because you've got that junction between warm and cold air. So that report, it was by Valentina, I'm going to apologise because I'm not very good at my Italian pronunciation, Maraccioni, who works at UCL. Chris Sanders, who is very well respected and has been a guest with some of these webinars in the past, and the late Neil May, who worked at the time for the STBA, very highly thought of in the condensation and moisture movement circles. But that report showed the importance of making sure that the details were there to ensure a well insulated and healthy envelope with reduced moisture levels, and that you couldn't achieve that without attending to the insulation at window and door reveals, especially when applying internal wall insulation. So the report, it's out there, it goes into huge depths about different buildings and wall depths and overall window percentages compared to, external walls. And depending on the window area, the heat loss in some properties can show equivalent levels where you could apply 140 mil of insulation to the wall internally, but not doing the window reveals compared with sort of 60 millimeters when insulating those. So really, you need to put something into the window reveals. Something is better than nothing. We are aware that especially in refurbishments, you maybe don't have that space to be putting in a lot, because otherwise, you might be going from sort of quite small windows if you have like a Georgian property. I know in my previous flat, they were quite small windows. To actually insulate them, I would have lost a lot of light. But things like the space therm, either as wall liner cut down or some of the other boards, depending on the parameters of your building, that with, even sort of 20, 30, 40 millimeters of insulation, even 10 mil is going to make a huge difference to not having an insulated window reveal at all on the overall energy efficiency, and reduce the risk of condensation forming at those window reveals.
Brilliant.
I just ask a quick question there. As far as the window reveals, that's one obviously key point in that it gets super cold, or it could do. But what about the junction between floors? Is that, because I remember when we first moved in here and we looked at internal insulation, it was a case of, the more I looked into it, it was like every ceiling, every floor, we really need to go all the way up, and then all of the rafters, all the joists are pocketed into the walls, and for that reason we were just like, there's so much risk, and we moved away from it.
It's a huge issue, and sometimes actually that balance of where your beams are and joists are actually fixed into your wall, you've got to be careful that you're not actually creating something that's going to have no heat getting to it. So it's that balance again we've talked about. If you've got too much insulation, are you actually going to stop that wall remaining dry and allow it to absorb moisture? So there's that catch-22 where you might actually be better off not putting much insulation there. Draft proofing is possibly your best option at those points, and a thin layer of something that's a permeable insulation to just mitigate some of that heat loss, but not to mitigate it to the point where your wall could be sitting wet and potentially introducing rot to your joint ends. It's probably where something like woofy could help, because we can look at what the moisture could be in that wall, not necessarily how it wraps around, but then there's also things like you can do cold bridging calculations, which will actually look to see whether there's a problem there. You can get more complex woofy analysis when you get into 3D and things like that. Not generally needed, but sometimes if you're going for a really deep retrofit, it's important. But for sort of like energy efficiency for your own building, there are ways that we can look at it and revise.
Okay.
Brilliant. Okay, thank you very much to all the Proctor team here, Adam, Pam, James, Bracken, Johnson, not Jones. I should know your name, James, I apologise. So really great, love how you guys answered the questions. Fantastic job as always. And Tim, thank you so much for joining us. I was aware of the project we were working on with Adam for your house with the roof shield. And when he said to me about this YouTube channel, I thought 100,000 followers, how's he managing that? And when I started to watch the videos, I really got it, because they're fantastic. So as I say, if anyone hasn't had a look at those, please do. So thank you very much for joining us, Tim. We really, really appreciate you coming along today.
That's all right. It's great to be here.
Definitely.
Good, and thank you very much to our audience. If you have been at previous webinars throughout this year, thank you so much. It really, we wouldn't be here doing these without people to watch them and attend them and learn from what we've been talking about. And as I said earlier, you will receive a follow-up email. So of course, there'll be the usual stuff on there, the link to download your personalised CPD certificate, a link to a replay, which you can circulate to friends or colleagues if you think any of them will find it of interest, and also a link to a survey. So this one for me is really important. We really want to hear what's good, what could be better, and any ideas that you want to hear about for next year. So we really want to keep doing these to help benefit, our customers and the industry. So any ideas that you'd like to hear a little bit more about, we will try and deliver that in the months next year. So as I said, as a little incentive, we will be picking out at random one of the survey responses, and we will pick out at random. I know you hear about these and suddenly the best customer gets the hamper. We're not like that. We will pick out at random on Tuesday, so please send it over to us by Monday. And it won't be a Christmas hamper full of Proctor stuff, and you're not going to get samples of Roof Shield. It'll be a lovely things you can share with your family and friends over Christmas when we're all in our bubbles, hopefully. So thank you so much. Really, fantastic. Well done to the marketing team behind the scenes and in front of the scenes. It's been absolutely brilliant for the Proctor Group to have been doing these webinars during this really, really challenging year. I'm so proud of everybody, so thank you. And we will see you all next year on Friday, the 29th of January, where our topic will be the physics and applications of construction membranes. So new content, new information, and also, touching on some of the points we covered last year for anyone who's revisiting our webinars. So have a fantastic Christmas and a Happy New Year with your families. I hope you've got your tree up. I used this webinar as an excuse to my husband. I said, we'll have to have that up in the background. So we got it up at the weekend there, much earlier than we usually would. So I was pleased. So yeah, have a great time and enjoy the time, with friends and family. And we will see you next year. Thanks very much.
Thank you.
Bye, everyone.
Bye.